Okay, so we're going to start looking at modulus function. We've already seen a bit of modulus when we did GPs, and we did the sum to infinity where the modulus of r was less than 1, sorry. So modulus of x in this case, always written with the two lines either side, and it basically means the size of x, or sometimes called the magnitude. We do a lot with modulus and magnitude in further maths next year as well. So it basically means ignoring the sign and just the size of the number. So modulus of 5 would be 5, but in the same way the modulus of minus 7 would be 7, because it's the size of the number ignoring the sign. Okay, so we can apply that when we look at graphs. If we want to look at the graph of y equals the modulus of x, when we put minus 3 into the modulus of x, y will actually be 3, okay, because we ignore the signs. So when x is minus 2, y will be 2. When x is minus 1, y is 1. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. And when x is 3, y is 3. Okay, and if we plot that on the graph, I've actually put a blank version of this onto the assignment as well, so you can print it off and draw it if you want to. But we've got when x was minus 3, y was 3. We've got minus 2, 2, minus 1, 1, 0, 0, and then 1, 1, 2, 2, and 3, 3. So you can see we actually get this V-shaped graph. Okay, and in fact, what you will see with any modulus graph is anything below the x-axis actually gets reflected up. Okay, and you'll see that with the next one that we do in a moment. But anything below the x-axis, because we're only looking at the size, we're looking at the magnitude, anything negative becomes positive, we'll see this happen with the graphs. Okay, now if we actually just fill this in, what you should see, the part of the straight line, I should say, to the right of the y-axis is the equation y equals x, and you should recognise this line here is y equals minus x. Okay, if we look at the second example, so this one, first of all, we're going to sketch the graph of y equals 3 minus x. So you might want to set out a little table of values. So if we do when x is, we'll do the same as above, minus 3. Don't know if it'll all fit, but we'll do minus 2, minus 1, 0, 1, 2, and 3. So when x is minus 3, 3 minus minus 3 is going to become a plus. So that's going to be 6. If x is minus 2, 3 minus minus 2 is going to become 3 add 2, which is 5. When x is minus 1, we're going to have 4. When x is 0, we'll have 3. And then we'll have 2, 1, and 0 there. Okay, so if we plot those, now minus 3, 6 isn't going to fit on the graph. The first one I can plot is minus 1, 4. Then 0, 3. 1, 2, 2, 1, 3, 0, and I'm actually going to keep going now. So I'd have 4 minus 1, 5 minus 2, and 6 minus 3. Okay, so if we draw a straight line through those, that's the graph y equals 3 minus x. So on this axis, if I'm going to draw the graph of y equals the modulus of 3 minus x, basically this part of the graph is going to stay the same because it's above the x-axis. Okay, so down to 0, what have we got? 3, 0 from minus 1, 4. That part of the graph is going to stay exactly the same. And then this part below the x-axis gets reflected up. Okay, so 4 minus 1 is going to go to 4, 1. 5 minus 2 is going to become 5, 2. And 6 minus 3 is going to become 6, 3. And then we'll end up with this graph for y equals the modulus of 3 minus x.